Hello students, welcome back. Let's solve a question based on the Newman projections from the isomerism topic. So let's get started. First, let's see what are Newman projections. Newman projections are a two-dimensional representations used in organic chemistry to visualize three-dimensional conformational structures. What does that mean? Say, if I have to write ethane molecule, generally we write ethane like this. When we write two-dimensional structure like this, and if there is a rotation of carbon-carbon bond, the positions of hydrogens cannot be represented properly. In that case, we use the Newman projections. For that, what we do is, if this is carbon number 1, we write it as a dot and we show that it is attached to 3 hydrogens like this. And this is carbon number 2. That is a rare carbon. This is front carbon and this is rare carbon. So since we cannot see that as it is exactly behind the first carbon, we try to write it like this, a spherical shape. And what about these 3 hydrogens? We write it like this. So now when we do the carbon-carbon bond rotation, it is easy to show the positions of the hydrogen. Say if I rotate this carbon by 60-degree angle, so then what happens? All the hydrogens will be on the same plane. So you can say that this hydrogen is exactly behind this and same with these 2 hydrogens. So that means we call the conformation as eclipsed conformation. So because we rotate the angle, we get different structures and we call these structures as eclipse structure and staggered structures and skew and gauche, etc. Now, so in this question, you have to identify the correct structure of 2,3 dimethyl butane. So how do you do that? You can either do this directly or you can convert the Newman projections to the simple structures and then verify whether the name is 2,3 dimethyl butane for that molecule. So I'm going to give you a simple tricks how to convert the Newman projection to two-dimensional structures. So how to do that? Start from this carbon and the rare carbon. So there is carbon here and here. You write those 2 carbons first. And then this carbon is attached to what? It's attached to methyl and ethyl. So CH3, CH2 and it is attached to hydrogen. This is a front carbon. This is a rare carbon attached to methyl and then we have methyl and hydrogen. So let's write that also. You can write anywhere. It doesn't matter. It should be on this carbon. That's it. So this is how you can write. Now let's give the UPAC name. So choose from head to tail like this. Choose the longest chain like this, making sure that the substituent locants will be having the least possible number so that it will obey the lowest sum rule. So now what will be the name of this molecule? It is 2,3 dimethyl. In the longest chain there are 5 carbons, hence it will be pentane. But in the question it's about butane, so this is not the structure. So let's check for the second molecule. So again, you write this carbon and this carbon, that is rare carbon. This carbon is attached to methyl hydrogen. So here you can observe this is eclipsed, right? It doesn't matter whether it's eclipsed or staggered. You just have to convert the Newman projections to the two-dimensional structures here. So the rare carbon is attached to methyl hydrogen. So methyl hydrogen and hydrogen. So let's give the UPAC name for this. So we can start numbering from here 1, 2, 3, 4 so that this will get the substituent. If I would have started from here, this would have been 3 methyl. So that's not correct, right? So this will be 2 methyl butane, but it's not dimethyl. So you can ignore this also. So for the third one, I'm going to tell you how to write it in one step. Like say for here, carbon is attached to 3 hydrogen, right? So let's write it as CH3. And then this is the carbon, right? The rare carbon attached to CH2CH3. See, this is much easier. You can save some time. And also it is attached to methyl and methyl like this. And let's quickly give the UPAC name here. So start from here. right? So it will be 2 comma 2 dimethyl. So here it's 2 comma 3, so not possible. So our answer must be D. However, let's verify it. So what I'll do, one more simple trick, like you can still save a lot of time this way. So if you have a molecule like this, start numbering from here, right? 1 end, then take this as 2, and then the carbon is there, call it as 3. It is attached to either this or this. However, you take it as 4. So 1, 2, 3, 4. At second position, you see there is a methyl. At third position also, you see there is a methyl. So 2 comma 3 dimethyl. How many carbons are there in the longest chain? 4. Therefore, it will be butane. Therefore, the right answer is option B. If you still have any questions on this Newman projections, ask your doubts in the comment section. I'll help you with that. Thank you for watching this video. Until next time. And please don't forget to subscribe the channel if you haven't done.